Fine. So in the last week, we started about lexical analysis, and we have seen three things: something called as a token, okay, then there is something called as a lexeme, and something called as a pattern. Okay, what is the difference between all this that we have seen? And so, for example, uh, uh, let's say if you have a variable name, so the name of the variable is actually a lexeme. Okay, so if you write integer abc, so abc is a lexeme. Okay, but the regular expression with which it matches is called a pattern. So okay, so the pattern defines the particular regular expression, okay, by using which this lexeme belongs to that category. Okay, and the token, the name of the variable or a function is identifier. Okay, this is an identifier. So the token category is identifier that we have seen. Okay. Then we were discussing about the various examples. Okay, and we have seen that given this function limited square, there are so many tokens written, okay, for this. Okay. So you can see everything like float, limited square, bracket, x, closing bracket, that is a kind of a token. Okay, for every token there is a regular expression, and according to regular expression the things will be compared, and the lexical analyzer will return you the set of tokens. Okay, so you can see there are so many tokens like float is a keyword, limited square, okay, it's an identifier, opening parenthesis is one token, x is again a token, identifier, right? And this closing parenthesis is again a token, and so on that we have seen. So last time we were discussing about the difficulties in doing tokenization. Okay? So the lexical analysis is entirely dealing with the issue of what is known as a tokenization. Okay, and the thing is the tokenization is not that easy. Okay, so what makes it difficult? Okay, so let us try to understand by an example. So you must have seen this double star, okay, as an operator in programming languages, okay, which would indicate exponent operator. This is like E is equal to M into C square. Okay, so this star star is actually uh, particular exponent operator. Okay. So what is the case is uh, just by seeing this star, I cannot say star means multiplication. I have to look ahead and I have to see double star. Okay. Again, I have to look ahead and I have to see this two. Once I get this two, I will be able to know that this double star, okay, that would form a one token and which is operator, and that operator is exponentiation operator. Okay, so the issue is uh, just star is not sufficient. Okay, after star there are many possibilities, right? A star B. So after star there is a name of a variable. Okay, sometimes it is like A star star two, which means there are two occurrences of star. So this is an exponent operator. Okay, this is an exponent operator. So we have to really go ahead in the input, and after going ahead in the input, we need to decide actually what is the corresponding token. Okay, actually we need to also see the two before A star star two. So first we have to stand star, then second star, then two. So then I can determine that this two star is operator. Okay, this two star forms an operator. So how to do this? Okay, uh, that is very important. So here there are how many tokens? E 1 equals to second, M third token, star fourth token, C fifth token, star star 6, and 2 7. There are total 7 tokens are there. Okay, and E, M, and C are identifiers. Okay, and the attribute is pointer to the symbol table entry. While star is a multiplication, while star star is an exponent operator. 2 is an integer constant. Integer constant. Okay, so uh, see, with respect to certain programming languages like Pascal, okay, this is not an error. This is not a lexical error. You can see this. This is not a lexical error. Why? Because WHIL in bracket x equal to 0 will not generate any lexical error in Pascal, because it would treat this WHIL as one identifier, that is a function name, opening bracket, okay, uh, as a one token, x as one token, equals to as one token, 0 as integer token. So that way it will classify everything into tokens, will not produce any error. Okay, the subsequent phases may detect that error. Okay, so lexical analyzer, when it would detect an error, so I told you last time. Okay, can anybody recollect when the lexical analyzer will produce error? So I think we have seen the example in the last class. That was RE is not matched. Very correct. Yes. So more specifically, the remaining input, because we are scanning constantly the input characters, remaining input has not matching regular expression. Okay, the remaining input that we have does not have a regular expression. Okay, and which is matching with it, or rather I should say prefix of remaining input. Okay, prefix of remaining input does not match with, doesn't match with any pattern. RE means pattern. Okay, does not match with any pattern of the programming language, and so it will form an error. Okay, uh, so uh, uh, so lexical analysis errors are very limited. Okay, for example, even if let's say this is the case, so you can see here that a particular there is a if and fi. Okay, so if string fi is encountered, okay, so probably this is an error. In place of if, you have written fi, okay, by mistake. So fi is a misspelling of the keyword if, but lexical analyzer cannot tell it. Okay, so generally what we write it, if a is equal to something like f of x, f is some function, right? We write like this. And let's say by mistake, I misspelled if by fi, by mistake. In that case, what will happen? Fi, a is equal to f of x. That is what I have written. So here, fi is not actually valid, but rather lexical analyzer would not be able to detect it, because fi is valid identifier. Okay, this is a valid identifier, so the job of lexical analysis is to do tokenization. So fi is identifier, then bracket, then a is identifier, double equals to will be operator, f is again identifier, then bracket, x is again identifier. That way it will tokenize. So this misspell of if with fi is actually an error, but it would not be detected by the lexical analyzer. Rather, the later on phases will check that fi is not a correct function name. Okay, there is no function called fi in the program, and probably those phases would detect the error. Okay, but the lexical analyzer phase may not be able to detect the error. Why? because still I would be able to make the tokens out of the input. As long as I can extract out tokens, there is no error for lexical analyzer. Okay, so this is since fi is a valid identifier, okay, lexical analyzer must return the token for an identifier, and let's set other phase of the compiler handle this error. Okay, so see, have you ever thought that compiler does not end on giving one error? Okay, it's not like that on line number 5 you have error, so it just says that there is an error on line number 5, but it also says that there are presence of subsequent errors. Yes or no? Am I saying correct or not? Okay, compiler does not just give the first error, right? It tries to find out as many errors from the program as possible and gives you the list of all such errors. Am I saying correct or not? Yes. Yes. Okay, so how this is possible? How this is possible? Because generally one error is detected by some phase of the compiler. It's an error. So compiler has a phase. Okay, compiler has one thing that is called error detection and then recovery. Okay, so this is a very important phase of compiler. Okay, so not only it detects the error, but also tries to recover from the error and goes ahead in the input stream, that is a program, and tries to find out the next set of errors. Are you getting what I am saying? Yes. Compiler not only just detects the error, but tries to recover from the error and go ahead in the input stream, okay, to find out more set of errors. That means if it just stops at first error, you need to correct that error, then it will give you the next error. Okay, it is not very good, not very efficient. So this is for that compiler has to recover from the error. Okay, there should be some sort of recovery, and then after recovering from the error, its effort should be in a direction to find more set of errors. Yes, are you getting what I am saying? Yes, Jinal, Jayesh, Harsh. Yes. Okay. Okay. So this recovery. Okay. So you can see here. Okay, this recovery technique. Although it confuses the later phases. Okay, but this is very much important. So what kind of recovery techniques are there? Okay. We will see in detail later on, but you can see deleting some extra characters, inserting a missing character, replacing a one character by another character, or transposing to adjacent characters. This could be some possible error recovery actions. Okay, so what I wanted to say, suppose you by mistake put two semicolons. Okay, it's an error, so it will report an error. Okay, but in addition it will remove one semicolon and then go ahead. Okay, why to go ahead? To find out more set of errors. Okay, so what it can do, it can remove, it can replace sometimes. Okay, it can insert something. For example, you missed any semicolon, so it will insert semicolon and go ahead. Definitely it will give you the error. Okay, it will report an error because you missed it, but in order to find next set of errors, it uh, programmatically it does something. Okay, and go ahead. Okay, so it can either insert, it can remove, it can replace, or it can modify a few characters so that it can find the next set of errors. This kind of thing is called a recovery, and basically this is called a panic mode recovery. This has a name, panic mode recovery. Yes, are you able to get what is the meaning of panic mode recovery? It is the simplest form of recovery technique. Compiler analyzer has various ways to do the recovery, but I hope you are getting right. Uh, uh, yes, yes, okay, fine, fine, fine. So let us go to the slides back. So panic mode recovery, as I mentioned, delete successive characters from the remaining input until the analyzer can find a well-formed token. It may confuse the parser. Okay, this is a secondary issue because if you insert or delete something, later on faces may be confused because of that. Okay, these are the possible actions. Okay, we will also see in detail while covering syntax analysis these things. Okay, deleting characters, replacing or transposing characters. Okay, so you can see that Fortran example is given. Now, this is very important to understand. Although we don't use this Fortran, okay, I want to uh, introduce one issue. Okay, so this is one thing. Earlier, identifier can have spaces. Okay, uh, so you can have a variable name with spaces in between. Nowadays, it is not right. So this do, then space, then 5, then space, then I is equal to 1.25. This is the thing. Okay. Remember, Fortran is an old language. So do space 5 space I equals 1.25. So this what is the lexical analysis? It can this strip out this white spaces. It can remove these white spaces, and then it can make this do 5I is equal to 1.25. Okay, this is a correct interpretation because 1.25 is some number. Okay, 1.25 is some number. So definitely the do 5I it should be what is what the right hand side of the equals to is some number, floating number. So the left hand side should be what? It should be, what is that token? Do 5I together. Identifier, very correct. It should be an identifier. Okay, but see, in the same language, you are very correct. There is, so the, if you do it like this, okay, then I have 3 tokens. Which 3 tokens? One token is do 5I, as you mentioned, it is an ID. One token is equals to, which is an operator. And the third token is 1.25, it is a floating number. Okay, there are 3 tokens. But when you will be able to realize that this is correct? Okay, to understand that, let us take second expression. Okay. Just a one change, do space 5 space I equals to 1.25. Now you see, earlier there used to be a point, and now it used to be a comma. So this is just one change. Do, okay, then space 5 I is equal to 1.25, and this is a looping construct like a for loop. Okay, where 5 indicates increment amount. Okay, so each indicates increment I equal to I plus 5, like that. I starts from 1, I plus equal to 5, every time it increments by 5, and I should be less than or equal to 25. This is what is the normal meaning, right? I initialize the value of I from 1, every time I increment by 5, and I check up to 25. So that many times this do loop will be running. Okay, are you getting what is the meaning of do 5I is equal to 1.25? Is that correct or not? The for loop starts from 1. Okay, every time I compare with 25, if it is less than equal to, it will go inside. And after completing one iteration, I will be incremented by 5. Because that is what is the interpretation of this statement from for loop perspective. Is this clear? Yes. Jinal, then Jap, Yash. Am I saying correct? Harsh? Yes. Okay. So now you tell me, if you go according to this, can you say do 5i is identifier? Is this ID now? Do 5i is ID? Yes or no? No. Very correct. What are the things? So in that there are three tokens. Do is one token which indicates some kind of loop. 5 is one token which specifies amount of increment I equal to I plus 5. Then I is again one token, equals to 1, then comma, then 1 comma 25. So in here do is one token, 5 is one, I is another, equals to is 1, then comma, and then 25. So total how many tokens are there? Total how many tokens are there? Do is some keyword, 5 is some increment integer number. So how many tokens are generated here? 7. Earlier, Harsh, how many tokens were there? If you have do 3. Okay. Okay, now you tell me, when can I say it is actually do 5i is an identifier or do 5 and I are different tokens? When can I say, can I resolve this ambiguity that do 5 and I are different tokens or do 5i is a one token identifier? Okay, for that, for making that decision, what should I do? I have to go ahead till what point? Till what point I have to go ahead, or till comma? Jap is very correct. Do you agree with Jap? Jayesh, Harshit, Yash, yes? Others, okay? I hope you are there, right? 65, right? Uh, so, uh, uh, so I have to actually go ahead up to this point. Okay, if it is a dot, which means it is do 5i is an identifier. If it is a comma, which means do 5 and I are different tokens. Okay, do is a keyword, 5 is a number, I is identifier. That so depending on how much look ahead I see. So depending on whether it is a dot or whether it is a comma. Okay, uh, actually we are checking. Okay, whether do 5i is a identifier or do 5 and I are different tokens. Okay, and so very important thing is look ahead. We need to actually look ahead in the input stream. Okay, and then we need to decide whether the token I am returning is correct or not. This is an issue actually. How much to look ahead? Okay, how far I should look ahead? Okay, that etc. Many things are needed to be resolved. Clear what I'm saying? Yes. Okay. Fine. So for that, there is something called buffering technique. Okay. So because why we need a buffering technique? Okay. See, I already shared this PDF. This is a book PDF. Okay, old book PDF. Okay, and very much useful to understand few things. I'll take a help of this as well. So what is the need of buffering technique? Okay, this is a lexical analyzer. Okay, and what is the need of buffering technique? Okay. So, so we first will mention a two buffer input scheme. Okay, remember look ahead is necessary. Let me look ahead is necessary, right? You see this paragraph, input buffering. So the look ahead we cannot avoid. Okay? So to do this efficiently, some efficiency issues are there. Okay, because the programs are very large. Okay, and to do this faster, we need an efficient way to do lexical analysis. So for that, this input buffering techniques are there. In two buffer input scheme is that it is very useful when look ahead on input is necessary to identify tokens. Many a times look ahead is necessary, right? So then we introduce some useful techniques for speeding up the lexical analysis. So remember, you must know the purpose of why we study this input buffering. So the purpose is efficiency, that is to speed up the process of doing lexical analysis. Okay, so we'll use this buffering techniques. Okay. And actually, we will also use this function ungetC. I'll tell you, uh, but right now you remember to push back the characters, to push look ahead characters back into the input stream. UngetC is a function, just like getC is a function. UngetC is a function. What it does, it push backs. What it push backs? The characters, look ahead characters, because I need to do look ahead, and I once I look ahead, I find the token. Once I find the token, the next character, the subsequent character that I have already read, I have to push it again into the input stream back. Okay, and for that ungetC function is used. Okay, let me tell you the overview. UngetC, this is a function. Okay, just like getC is a function. Okay, ungetC is a function which takes two arguments actually, the character and input stream. Okay, our input stream will be standard input, for or it could be file. Okay, so see, ungetC, so let me tell you that, let's say a star star 2. Okay, so first I will detect first star, then second star, then 2. So whenever I get 2, actually I am getting 2 also. Okay, I see star, then second star, and then 2. But 2 is not a part of token. The part of token is star star only. So 2, I need to push back again into input stream. Because 2 I have already read, but I need to push back again into input stream, or rather than saying input stream, the standard stream, input stream. Okay, because 2 I have already looked ahead, but I need to actually start from 2. I cannot skip 2. Okay, so I need to do this pushback of the character already read so far, and this thing can be achieved by one function called ungetC. You can read the details, but this is the basic overview. Yes, Harsh, then Jai, uh, I mean Yash, Jap, are you getting what I'm trying to say or not? Jayesh, Jinal, saying yes. What about others? Yes. Okay. Okay. So, large amount. So the basic purpose of buffering technique is to improve the efficiency or performance of the lexical analyzer. Okay, and remember, spatial buffering technique is used. Very important. The first line: use a buffer divided into two halves, two n character halves. Now, what is this n? So, n usually is the size of disk block. So, depending on operating system specification, there would be a size. For example, sometimes 4096 characters or 2048 characters or even more, depending on specification. So, capital N. But remember, there are, so what is a buffer? We use a special kind of buffer which is divided into two halves. Okay, which is divided, okay, in two halves. Remember these two halves. Okay, and what is the length of the buffer? N characters. And this, what is n? N is the probably the size of the disk block, okay, that your operating system is using. Okay, so use a buffer divided into two n character halves. So remember, the buffer is a special kind of buffer which has two halves. Okay, and there are n characters in each. Okay, and one system command read and characters. So I hope you already studied this read and write and everything in operating system in detail. So you must be knowing that read and write, okay? So you can use that for reading purpose, okay? From the file or from the standard input. So you can, one system command, I assume it read capital N characters. And the last line you can read if you have fewer than N characters in the program. So this is actually program, right? Your input to the compiler is a program. So your entire program is like a character string, okay, array of characters. So those entire thing maybe your number of characters in program, okay, maybe quite large. For example, let's say number of characters in program is, let's say it is very great, let's say there are 1 lakh characters. So my buffer cannot accommodate 1 lakh characters at a time, okay? Even you can have larger than this number of characters, okay? So if you have 1 lakh characters, I cannot read 1 lakh characters at a time. So what should I do? How many characters I can read? N. What is N? Let's say N is 4096. So what I can do? I can read 4096 characters of your program at a time. Of your program at a time. Okay. So what I need to do for remaining characters, I need to again take the next set of characters, and I need to do this process again and again until I am done with the entire 1 lakh characters. Are you getting what I am saying? Are you getting what I am saying? Yes. Also, I need to maintain some pointers. Do I need to maintain some pointers? Like what is the beginning of the particular lexeme? Okay. So I need to maintain some pointers like begin lexeme pointer, which indicates the starting position of the, which indicates what? Starting of any token. Okay, that is lexeme. And there is also a forward pointer. Remember, I also need a forward pointer because I need to scan and go ahead, okay, to find out what is a token. So I need to increment the token. For example, increment the pointer like star star 2 equal to a star star 2. So I need to increment. So a is a beginning of, star is beginning of the token. Okay. So the lexeme begin pointer points to star. Then I need to increment the forward pointer. So first it will be forwarded, so it will point to second star. Next time it is forwarded, so it will point to 2. Once it points to 2, it will be able to find out I actually went ahead. So it again pushed back the 2 and set the pointer. Then finally it detects that star star is actually a token. So I need to actually maintain the pointers. Okay? And remember, your program may not be multiple of n. Like 1 lakh is not a multiple of 4096. So sometimes what happens, there are fewer than 4096 characters at the last time. Okay. In that case, suppose there are 2045 characters in the last section. There is a special character called end of file character. So that end of file character indicates that it is an end of the program. Okay. So this is the thing. So as I mentioned, okay, there are 2 pointers used. Okay, there are 2 pointers used. Okay, so you can see this is a stream of characters stored in a buffer. Buffer is nothing but a set of characters stored at some memory. Okay, and you can see this is a lexeme beginning. This is a lexeme beginning, and then forward scans ahead to find the pattern match. Then it finds that star star is a correct match. Then it will realize that star star is a token. So 2 pointers are maintained. Okay, The string of characters between the pointer is the current lexeme. Okay. So starting from lexeme beginning, before this forward, whatever the things are there, this thing is what is known as the uh, particular token. I hope in your lab session you must have used YY text. YY text. Have you used that or not? Yes. Okay. What is that? Jeet, Jayesh, YY text. What is that? It is a character pointer, means kind of string. Can I say? It points to beginning of string, right? So so now are you getting how this YY text is? YY text points to the lexeme begin pointer. YY text pointer is nothing but the lexeme begin pointer. Are you getting or not? YY text is a lexeme begin pointer, and there is internally some forward pointer which increments based on your regular expression. It will find out the end and extract out those characters. And if you print this YY text will be the matching string. Okay, matching string. Okay, YY text is of course a pointer, but you can use that pointer to print a matching string. So, lexeme beginning is like a starting pointer in lex YY text, and once it goes ahead and finds this would be the content of YY text pointed by YY text. Okay. Remember, I already mentioned last time, comments and white space are the tokens. Okay. Actually, the tokens, they are matched by patterns, but they are not having actually any token returned. They are actually having patterns, right? White space is a blank or a space or a new line, one or more occurrences of that. Okay. But they yield no token because it's not important for parser. That's why I ignore them. Now I have two algorithms. Now remember, so the points I want to focus are this. The first point is that for efficient lexical analysis process, okay, I use a buffer. Buffer is divided into two halves, exact two halves. Each buffer size, each half is of size n. N is a number of characters that you can read at a time. If you exhaust the input, end of file character is the thing. Now, my question is how we can use this buffer for efficient implementation of lexical analyzer. And for that, I will tell you two ideas. Basically, two algorithms I will. Okay. One, a simple algorithm, and the second with sentinels. Okay. There are two ideas to implement this. One is a simple idea and a sentinel. Both idea use what? Both idea use this concept of buffer pattern. Okay. So you can see this. So forward pointer, if it is the end of first half, okay, so this you can see this code. If the forward pointer is end of the first half, then reload the second half. Okay. So what is the issue is, can that happen that your lexeme begin starts in the first half but ends in the second half because there is no space. Okay, so the remaining characters, let's say I have this C equal to A star star 2. Okay, the first star is actually the last character of the first half. Character of first half. So the second star is actually the first character. of second half. Are you getting what I am saying? There are two stars, right? Star, star. So the first star is in the first half of it. There is a large memory space divided into two halves. Okay. So the beginning of the token happened in the first half, and because there is no space in the first half, in the second half, the remaining portion of the token went. Is that possible or not? I mean, in second half, there is a star also, two also, and remaining input. This is just an example. Yes or no? See, I'm just giving you an example. The text is too large. Okay. But what I'm saying is uh, the text may have started, the token beginning has been started in the first half, and uh, since there is no space in the first half, uh, the remaining input went in this is required to be in the second half. So if the forward pointer is at the end of the first half, then you have to reload the second half. What do you mean by reloading the second half? That means remaining input, remaining set of characters from the program, you have to load in the second half. So it's like this. This is the first half. This is the second half. Okay. There is a, then there is a star, and now this star is the last character of the first half. So the next star went here, and then there is a 2, and then probably the semicolon and the next set of characters. Okay, but what I'm saying is Lexeme started from here, beginning is here. Okay, but I have to actually forward in this, I have to look ahead, and then once I see this 2, then I can say that this star star makes a token. So if you, this can happen. Okay, so if forward is at the end of the first half, then what you have to do, you have to reload the second half. Reload the second half means read the program, next set of characters, and load it into the second half. And the forward pointer I need to increment. Same way, if you are at the last, so for example, this can also happen like this. So you are A, and then star is here, and now this buffer is over. This buffer is over. So this buffer has to be, the first half has to be reloaded. Reloaded means what? Overwritten. Reloaded means overwritten. So earlier there may be earlier set of characters of the program. Okay, now it is reloaded. That means next set of characters will be overwritten over the first whatever it was earlier. Okay, and now, so the same thing can happen here. Star is here, then this star, the next star is here, and then there is a 2. Same example I am taking, A star star 2. Are you getting what I am trying to say? Are you getting? Sahil, Jay, Yash? Yes, others like Saloni, Jayesh, Jeet, Harsh. Are you getting what I am saying, Harshit? Yes. Okay. So what I am saying is, if the pointer, if the forward pointer is the end of the first half, then you have to reload the second half. So if you are at the end of the first half, you have to reload the second half and increment the forward pointer. Why do all this? The reason is to find tokens, valid tokens. Else, if the forward is at the end of the second half, then you need to reload the first half. Reload the first half means you need to take input from the program and load the buffer, override the buffer contents by the new content, and move forward to the beginning of the first half. So it is not always the case that you are either forward is at end of the first half or end of the second half. It is also the case that sometimes you are at the this is not a end, you are starting, and this all are the things in the same half. So if it is not so, then forward will be incremented just by 1. Forward will be incremented just by 1. Okay, so let's say this is you are here, You are here, and this is not the end of the first half or second half. Then forward will be incremented to this place. Again, this is not the uh, end of the first or second half. So then forward will be here. Then it will determine that this star star is a total. Okay. So what I wanted to tell is how many times you need to do comparison in order to increment. This all is increment of forward pointer. Increment of forward pointer. My question is, okay, how many comparisons are needed to increment the forward pointer if you are not at the end of first half or second half? Are you getting my question? You are not at the end of the first half, you are not at the end of second half. Then how many comparisons are needed to increment the forward pointer? You see the code. Okay, this is a code or pseudo code or algorithm. You are not at the end of first half, so this condition is wrong. You are not at the end of the second half, so this condition is wrong. And then you will come here and you will increment the forward simply by 1. So how many comparisons will be needed? Anybody? Harshit, Jeet, Yash? So I need to actually compare the forward pointer, whether it is at the end of the first half, it is at the end of the second half. So can't I consider this as a comparison? This is one comparison, this is second comparison. Then I will come here, 2 comparisons, very correct. Yes. So remember, this is the case. What I wanted to say is, as I mentioned, we read AND characters, okay, into first half with one system read command, rather than invoking a read command for each input character. Because if you take one by one input, it would be too time consuming, one character at a time. Okay, so I read the entire set of characters and characters in the input. Okay. So what I wanted to tell is, in this scheme, this is the scheme, figure 3 point. Okay, in this scheme, one comparison is required here, one comparison is required here. Then I will, so if both are false, then you will increment here. Okay. So that means what? We must check each time we move the forward pointer that we have not moved off the half of the buffer. Yes, definitely we need to check that we are not, let's say this is a half, so that we are not moving ahead of the half. Okay, if we do so, then we must reload the second buffer, the other half. That is our code. Okay, so you see this line, except the ends of the buffer halves, the code in figure 3.4 requires 2 tests for each advancement of the forward pointer. Forward pointer, you need to increment one time, that means you need to do 2 tests. Okay, so we can reduce, so I want an improvement over this. So we can reduce the 2 tests to 1 if we extend each buffer half to hold a sentinel character. Earlier I don't have a sentinel character. Now I use a sentinel character. This is a sentinel character, EOF. Okay, so now I will reduce this number of comparisons by seconds way. And what is the second way? Again the same strategy, but I will use something called sentinel characters. Okay, sentinel character, for what it means is end of file character. I'll take one special character, end of file character, and at the end of each buffer half, at the end of each half, there is, okay, EOF. You can see this is a buffer half, this partition, you can see this is a partition. Just before that partition, there is a EOF, which would indicate that this is the end of buffer half set. Okay, same way, if you encounter the EOF at the end of second, then it would be here. But if the input is exhausted, for example, this is my end of the program, E equal to mc square, this is my end of the program, then there will be end of file character, okay, before the buffer capacity expires. Okay, so there are three ways, there are three different ways in which EOF can come. The one way is at the end of first half. Okay, you are at the end of first buffer half. Sorry, it's half. Same way at the end of second half. And the third is what? Your input is already over. So the third is at the end of input. So your program is program characters are exhausted. Buffer is still there, capacity is there in buffer, but now there is nothing to read. So that end of file indicates the end of the program. Are you getting these three places of end of file? Okay, I am using end of file as a sentinel character and modify the algorithm, and then I will tell you what is the improvement of that algorithm over the first algorithm. Okay. So what I wanted to tell is, so these are the pitfalls, okay, of this algorithm one. I discussed already, so you just read that. Read. Okay. What are the pitfalls? Okay, amount of look ahead is limited. Okay, uh, two comparisons not that good, and limited look ahead makes it impossible to recognize tokens in situations where, remember, if your size of the token is greater than the uh, okay length of the buffer, it would be impossible to recognize the token. This you can understand, right? Your token start at some position, but your token length is greater than the buffer. Okay? So let's say the 4096 is the length of the length, and your token is 5000 length. Your token is 5000 length. So if and see, both buffer pair together, if they make 4096 and your token length is 5000. Okay, so what will happen? You will not be able to recognize this token. Why? Because you will overwrite the buffer pair, okay, and the last four characters, okay, will not be detected because you will meanwhile override the string, okay, and that's why if your token size is greater than the length of the buffer, it is impossible for you to do this. These are the pitfalls. I hope you are getting right. Getting or not? What I'm trying to say. Yes. What about others? Yash, Harsh. Okay. So there is a second way. So please see this second way. Once this is over, I'll stop. What is the second way? So this is a partition. At the end of each half, I put end of file. So you see, I increment the forward, okay, and there are three cases. So if forward pointer is an end of file, then there are three cases. How many possibilities? कितनी possibilities है end of file के लिए? There are three possibilities, right? That end of file may be the end of the first half. That end of file is the end of the second half, and or that end of file signifies the end of the input. Okay. So if you increment a forward, okay, first you increment a forward, and then you check if the forward is end of file, that is a sentinel character. If it is so, then you will go ahead inside this. If the forward is at the end of first half, definitely, अगर आप यहाँ पे है, you need to load the remaining input in the second half. Reload the second half. This is a block IO. It will prevent you from moving ahead unless the input is read. Then you increment the forward by 1. Okay. Similarly, if you are end of the second, you are here, then you need to reload the first half and then move forward to the beginning of the first half, that is here. If you are not at the end of first half, you are not at the end of the second half, then you that indicates that is end of input, and which indicates that end of program, which indicates there is you need to terminate the lexical analysis. You need to terminate the lexical analysis, and this is the algorithm. Okay, so remember, this is a second scheme. Okay, this is a second scheme. Okay, you increment the forward, and if you are getting end of file, then there are three cases. That end of file could be the beginning, end of first half, end of second half, or it is end of input. So then you see this 3.6 look ahead code with the sentinels, okay, how it is advantageous to us. Okay. So how it is advantageous to us compared to the previous one. Okay, so you can read here with the arrangement of 3.5 like this. We can use the code in 3.6 like this. Okay, so most of the time you read this line. Most of the time code performs only one test to see whether forward pointer points to an end of file or not. Okay. Most of the time the code performs only one test to see whether forward points to an end of file. Okay. Only when we reach the end of buffer half or the end of the file, we need to perform the more test. Okay. Forward will be incremented, right? Only when we encounter end of file, okay, only when we reach the end of buffer half or at the end of file, we need to perform the more test. So you need to do this all things only when you encounter end of file. And end of file is encountered only in three situations, where if you are at the end of the buffers or you exhausted the input. So only in that cases you need to perform the more test. Otherwise, okay, most of the time the code performs only one test to see whether forward points to an end of file or not. So just this test is done. ये वाला टेस्ट ही होगा. अगर end of file नहीं है तो you will skip this entire portion and it come out. Okay. But if it is end of file, then you will go ahead and then you have to do more comparisons. Okay. So earlier it was not the case. Earlier it is strict to have this comparison, and this comparison if you are not at the end of first half or not at the end of second half. Are you getting the advantage? Harsh, Yash, Jeet, Jinal? Yes. Yes. So for buffer, so this is a scheme with sentinels. Okay, this is a scheme with sentinels, as I mentioned, and this is more appropriate. Okay, so I hope you understood the seriousness of look ahead, why it is important to do look ahead, and how can I do efficiently. The final statement I would like to comment is that I cannot read one character at a time. It would be too inefficient. So I have to read n characters at a time. I cannot just maintain one buffer. एक बफर नहीं रख सकते हैं, क्योंकि अगर आपके पास एक ही बफर होगा तो what will be the problem? If the length of the token is greater than the size of the buffer, it would not be possible to detect that token. And that's why I took the buffer halves. In buffer halves, there are two ways to implement the strategy. One strategy is, okay, you just increment the forward pointer after checking for the ends. But for that, you require two comparisons. Okay, so I used one more strategy with sentinels, which only when it is an end of file character, you need more comparisons. Otherwise, there is just a one comparison. Okay, Any doubt? Rahul, Saloni, Jayesh, Yash, Harsh? Any doubt up to now? Yeah. Okay, fine. So thank you so much. Uh, in the next lecture, that is on Thursday, okay, we'll see the next topic. Thank you so much.